Last class we started something called Legendre polynomial. At least I wrote this term, but I didn't mention anything about that. So let me do that in today's class. So if I have a differential equation in the form then we have a series solution of these things, a series solution. The solutions, if I write, it should be something like this: f0 p0 is 1, p1 x is x, p2 x is half of 3 x square minus 1, and so on. Depending on the value of these things, I should have a general solution, series solution. We called it Pnx. If you note that these things, there are other terms also are forming polynomials through polynomials. This is one polynomial, this is another polynomial, this is a degree 1 polynomial, this is a degree 0 polynomial, this is a degree 2 polynomial, and so on. So these solutions, individual solutions, they are forming the polynomial, are linearly independent to each other, and they are also orthogonal. Since they are orthogonal to each other and linearly independent to each other, obviously if they are orthogonal, they should be linearly independent. So now with using these polynomials, one can express or expand some function like the Fourier series. If you remember, in the Fourier series, the basis function was 1 sin x cos x sin nx cos nx, and so on. These were our basis sets which forming a basis, and I can expand a function in terms of them. Here, instead of having a sinusoidal function, I have some polynomials. They can form the basis, but before that we should also learn about this, how to get this and all these things. So let me write somewhere here in the right hand side few values of few polynomials. Say p0 x is 1, p1 x is x, p2 x is half of 3 x square minus 1, and so on. In order to remember how these polynomials are there, we have something called Rodrigues formula. Rodrigues formula. What is the formula? This formula suggests how to find out this value Pnx, and the formula is 2 to the power n, 1 by 2 to the power n factorials, nth derivative of the quantity x square minus 1 whole to the power n. If I evaluate, I am going to get these things. So let me do that elaborately so that you can have the idea of these polynomials. So first let us do p0 is a 0th order derivative, so I will, and here is 0, here is 0, so 1, readily it is there. What about the p1? P1, if I do p1 x, which I wrote here x, so I will going to verify that. So p1 means n is equal to 1, this is 1, so 1 by 2, the derivative will be first order x square minus 1, n is 1, so here I should put 1. If I make a derivative of this quantity, I will have 2x and this 2 will cancel out, so I will have only x. So these things is verified. I will have these things from Rodrigues formula. What about the next term? Let me erase these things because I am going to I need this space actually. So the Rodrigues formula, I once again write Pnx is equal to 1 by 2 to the power n factorial dn dxn x square minus 1 whole to the power n. This formula I have already written, so I am also going to use this for say p2x. How to write p2x? 1 2 to the power 2 and factorial 2, this is the initial term. Then d2 dx square, I will have x square minus 1 square of this quantity. This, if I have this, then I will have in the denominator 2 square, 2 to the power 2 is 4 and multiplied by 2, so it will be 8. And now the derivative d dx, when I make a first derivative of these things, I will have 1 2 term here, 2 of x square minus 1, and for this x square again a 2 of x term here. So this 2 will cancel out and I will have here 1 2. So it will be half d dx of xs cube minus x something like this. So it will be half, if I do that, it will be 3x square minus 1. If I make a derivative of this quantity, it will be 3x square, and for x it is 1. So half 3x square minus 1, which is written here, but I did not read in f3 p3, so I need to calculate that also. Let us do that. It will be just an exercise. So p3x I like to find out. So it should be 1 2 to the power of 3 factorial 3 initial term, and then d3 dx3 x square minus 1 whole cube, this. So first it is 8 into 6, 2 to the power 3 is 8, factorial 3 is 6, let me put that. Double derivative, I want to reduce one derivative. If I do that, it will be 3 multiplied by x square minus 1 square of these things, and for 2x I will have, for x square I have 1 2x here, this quantity. So here again 2 and 3 will cancel out with this 6. So I will have 1 by 8 d2 dx square x multiplied by x square minus 1 square of that. Again I want to, if I want, I need to reduce one order here. So d dx, if I reduce to one order, then I need to make a derivative of this quantity. So okay, let us do that in this way, the first derivative and the second derivative. So x square minus 1 first derivative multiplied by second one plus second one multiplied by the first derivative. So it is 2 x square minus 1, 2 x square minus 1, and then for 2x I will have another, for x square I have another 2x. I believe it is fine. 1 by 8 d dx of, if I expand it should be x to the power 4 minus 2 x square plus 1, this is one term, and rest term is plus 2 to 4 x square. So, 4 2 into 2 is a 4, let me write in this way. So, it will be multiplied by 4 x square. So, it will be 4 x to the power of 4 x to the power of 4 minus 4 x square. It comes out to be something like this. Now, if I simplify this, it will be 1 by 8. I try to calculate P3 x. It is 1 by 8 d of dx of this quantity, which is now something like this quantity. So, it will be 5 x to the power of 4, and then this quantity which is minus of 6 x square, hope I am doing correctly, and 1 plus 1 term is here. This one term will not going to be effective because the derivative is there. So, now if I make the derivative, it will be 5 x to the power 5 into 4 x cube minus 12 x, it will be something like this. So, it is, this is 20. So, let me write it, this is 20 x cube minus 12 x of this. So, we have already got the polynomial, but next I need to reduce a bit. So, if I take 4 common of that, so I will have half 5 x cube minus 3 x. Still I have a polynomial of higher order, and this is the form of P3. So, if I write here somewhere P3, which I find from Rodrigues formula, this up to this I remember, so I write it, but after P3 and P4 it is very difficult to remember, and you have already find that how difficult, not difficult, but the process is lengthy, because you need to calculate the derivative of different orders. For here P3 you need to calculate the derivative for third order. If you go to fourth order and fifth order, sixth order, it will be larger and larger. So, half 5 x cube minus 3 x square 3x sorry is my form of the Legendre polynomial of order 3. Now, after having the Legendre polynomial from Rodrigues formula, next we need to find out whether they are really, these things are really orthogonal to each other or not. So, how do we find out the inner product? By taking the inner product. But before taking the inner product, one thing I should mention earlier, but now I am mentioning, this function is limited to -1 to 1. So, there should be some limit, there should be some range through which these functions are related or are defined. So, this is the limit for that, because I required this because I need to calculate the inner product. So, now if I calculate the inner product, so let us find out. So, I am checking randomly. So, inner product between 1 and x, or if I write in terms of P0 and P1, I say P0 and P1 are orthogonal. So, if I take the inner product of these two things, I should have 0. So, really I am getting 0. So, let us do that. -1 to 1, P0 is 1, P1 is x dx, which is 0 because this is a odd function and limit is -1 to 1. Let us check, say, for P1 and P2, P1 and P2. Randomly I am checking. So, it is -1 to 1. What is my P1 x? half I take outside, x multiplied by 3 x square minus 1 dx. Now, when I multiply this quantity, the first term is 3 x cube and the second term is x. So, if I divide it, there will be two integration, one is 3 x cube and another is x. So, first one is also odd, second one is also odd. So, this quantity is also going to 0. Okay. So, now we can test with other terms also. I mean, say P2 multiplied by P3, you will get that again it will give you something which is 0. So, that means they are orthogonal to each other. Now, if they are orthogonal, that means they are potentially form a basis, but the important thing is that how to find out the normalization factor. So, normalization also we can find out. So, before doing that, I should write a general form also for normalization. This is a general form of normalization. So, norm of the nth order of Legendre polynomial is 1 divided by 2n plus 1 whole to the power of half. This is the relation. So, let us check whether really it is following or not. Really it is following or not. So, first P0, I want to find out the norm square of P0, which is nothing but inner product of P0 and P0. If I do that, then I will have minus 1 to 1, then the function 1 into 1 dx, which is how much? Which is nothing but nothing but 2. Okay, this formula I am making one mistake. It should be 2 divided by 2n plus 1. So far I remember it is 2 divided by 2n plus 1. Okay, I will check that. I will check that with this. So, since it is x, so x will be minus 1 to 1. So, that will be 2. So, what will be my P0? These things, it will be root over of 2. Let us check with the formula, whatever the formula I was reading. Initially I wrote 1 divided by 2n plus 1, but I find it is not matching. But if I write 2 divided by 2n plus 1, is it n equal to 0, then this quantity is not there. So, it is 2 with a root. So, I will have the same thing, 2 with a root. Okay, for 1 maybe it is easier. So, let us do that for x, the next one. So, what is the norm square of P1 x, norm square? So, it will be minus 1 to 1 x square dx, which is how much? 2 over 3. If I integrate, then it will be x cube divided by 3. If I put x cube minus 1 to 1, then it will be 2. So, 2 by 3. So, my P1 x seems to be root over of 2 by 3. Let us try to use this formula. If I put n equal to 1, then it will be 2 divided by 2 plus 1, 3. So, 2 divided by 3 whole to the power half, 2 divided by 3 whole to the power half. So far the formula is matching. So, finally, we will check for P2 and then we conclude. So, P2 again I am doing the same thing. So, it's when I make a square of this quantity, so 1 by 4 will be coming outside, minus 1 to 1, it will be 3 x square minus 1 square dx. So, it will be 1 by 4. Now, integration minus 1 to 1. So, it is 9 x square. Let me write it clearly. 3 x square is also making square. So, 9 x to the power of 4 minus 6 x square plus 1. dx over this quantity. So, 1 by 4 minus 1 to 1, this quantity, let me directly integrate that, why I am doing the integration sign or integrate it. So, it is 9 by 5 x to the power x cube minus 6 by 3, I am making the integration, sorry. So, it will be 5, it will be 3, and finally, I will have here x minus 1 to 1. So, 9 x cube x to the power 5 divided by 5 x cube divided by 3, 1 in x, 1 by 4. Now, if I put the limit, so this is odd, this is odd, this is odd, minus 1 to 1. So, that means this will give 2, this will give 2, this will give 2, because so 9 by 5 into 2 minus 6 into 2 by 3 plus 2. Okay, so finally, this value comes out to be 1 by 4 18 by 5 minus this 3 will cut to this 6 with 2. So, this is 4. So, this is minus 2. This is 4 and this is plus 2. So, minus 4 plus 2, I will have minus 2. So, now I will have 1 by 4 into 5 into 2 10. So, I will have here 8 divided by 5 and it will be nothing but 2 divided by 5. This value finally I am getting. So, this 2 divided by 5 is the value of P2 square, P2. So, norm of P2x, norm of P2x is nothing but root over of this quantity, and this formula that I have wrote here 2 divided by 2n plus 1. So, if I put n equal to 2 here, then it will be 2 into 2 4 plus 1 5, 2 by 5 root over of that. So, I will have 2 by 5 root over of that by doing all the extensive calculation, by calculating the inner product of that. So, we will roughly check that there really this formula is really working good, and also we find the normalized value of this quantity. Now, if I divide the every function with this quantity, then this function potentially be a orthonormal basis. There are actually another way to find out whether they are forming orthonormal basis or not, and this form I have already described, which is called Gram-Schmidt orthonormalization. Gram-Schmidt orthonormalization. So, Gram-Schmidt orthonormalization suggests that if you are given a set of linearly independent vector, if you remember, this is a set of linearly independent, in Gram-Schmidt say there it is giving like a vector, but here this is a linearly independent set of functions. Now, if I use the Gram-Schmidt orthonormalization procedure, I will return back these functions. So, let me do that quickly. So, what is the Gram-Schmidt orthonormalization? So, I am using the Gram-Schmidt orthonormalization process for a given set of function. This is a set of functions which is 1 x square, and in the previous class we show that these functions are forming a linearly independent, because if you do the Wronskian of that, it will not equal to 0. So, if I start with that, so what should be my p1 p0x first function? I know that this first function, if I write it as phi 1 phi 2 and all these things, then if you remember, it is phi 1 divided by mod of phi 1, this quantity. So, here phi 1 is 1 and mod of phi 1 is mod of phi 1 is minus 1 to 1 1 dx, inner product of these things in minus 1 to 1 limit. So, it will be 1 square is 1. So, this. So, first term is 1 divided by and square of that, half of that, because I am having the norm of these things. So, if I do that, then I will have it is 1 by root 2. So, my first function is 1 by root 2. So, these are the polynomials I wrote without the normalization factor. If I write this in the normalization factor, it should be 1 over root over of 2, it should be x divided by root over of 2/3 and so on, and this value I have calculated just before. So, here I will have my first value. When I make a normalization, I will have the first value, which is the first Legendre polynomial. What about the second thing? So, I have the first thing. So, second thing, how do I calculate? So, p1 prime x, if you remember, I put the prime because I still now I did not normalize that. It is the given function, second one, minus of the inner product of the function I will have. So, p0 x multiplied by p0. This was the technique. So, first function is first function. What is the inner product of p0 and x? It is minus 1 to 1. p0 I have already calculated, it is 1 by root 2. If I write it here, it will be 1 by root 2 x dx. This is the inner product. This inner product x is how much? Integration minus 1 to 1 x is nothing but 0, because this is the odd function. So, inner product is 0 here. So, I will eventually have my function, second function, just only x. Now, I have to normalize. So, my original p1 x will be my p1 prime x divided by the norm of p1 x. And what is my norm of p1 prime? Norm of p1 prime. So, norm of p1 prime x is integration minus 1 to 1, it is x. So, I will have x square dx whole to the power half of that, because I am making the norm. So, now if I do that, it will be x cube by 3 with minus 1 to 1. So, it is nothing but 2 over 3 with whole to the power half definitely. So, it will be whole to the power half. So, my second function is normalized by root over of 2 by 3. So, finally, I will have, so let me write it here in the right side. So, p0 I am having p0x I am having one term root over 2, p1x I am having x divided by root over of 2 by 3. This is my second term I am getting. In the similar way, I can do find the third term. If I do, let me do that quickly. So, my p2 prime x is how much? X square minus of p1 p0 with x square inner product p0 minus p1 of x square inner product p1. I suggest you to please go back to the lesson of where the Gram-Schmidt orthonormalization process were described, and this is the procedure we are following, exactly the same procedure that is used in calculating in the vector space. When some linearly independent set of vector is given to you, you are calculating the similar way how to find a normalized orthonormal vector out of that. So, I am doing the same thing. So, let me find out what is my p0 inner product x square. My p0 I have already calculated, it is 1 over root over of 2 minus 1 to 1 and it is okay both the and it is x square. So, x square dx, it will be 1 root over of 2, x square means it will be 2 by 3, x square will be x cube divided by 3, when you put minus 1 to 1 it will be 2 by 3. So, I will have the first value of my inner product, which is, let me write somewhere so that I should not forget. So, root over of 2 by 3 is the value of this quantity. What about the next quantity? The next quantity is P1 x square inner product, which is minus 1 to 1. What was my P1? P1 was my this value. So, let me write root over of 3 by 2 outside, then x multiplied by x square dx. X square is x cube, which is odd function, so it will going to vanish. So, I should not have the contribution of this. So, finally, what value I am getting for P2? I am getting x square minus this quantity, the inner product is root over of 2 by 3 and P0. P0 is my 1 by root over of 2. So, I will have something x square minus 1 by 3. I have something like this. So, now I need to normalize this quantity. If I do, then my P2 x will be simply P2 prime x divided by the norm of P2 prime x. So, norm of P2 prime x, P2 is given, P2 prime is given. So, I can calculate quite easily. So, let me do that quickly. Extensively I am showing how to calculate these things. I believe you can do that. So, I try to calculate first P2 prime x square. It is nothing but minus 1 to 1 this quantity x square minus 1 by 3 whole square dx. So, this is minus 1 to 1 x to the power 4 minus 2 of x square divided by 3 plus 1 by 9. So, my original function, so if I do that, then it will be x to the power 5 by 5 minus 2/3 x cube by 3 plus 1 by 9 with the limit minus 1 to 1. If I put that, it will be 2 by 5 minus 2 by 3 into 2 by 3 and plus 2 by 9. So, it will be 2 by 5 minus, this is 4 by 9, this is 2 by 9. So, I will have 2 by 9. So, it will be 45 and 8 by 45 this quantity. So, this quantity is square. So, if I make a root over of that, so if I write it here, my P3, P2, then P1, P2 is this quantity root over. So, root over of 45 by 8, then multiplied by that quantity x square minus 1 by 3, this polynomial. So, now if I slightly modify these things, so root over of 45, I can write 4 into 9, 5 into 9, and then it will be root over of 3 if I write it, say it will be something like 5 into 9 divided by say 2 into 4. So, it is this quantity. I can take this 3 and 4 outside. So, it will be simply 3 by 2 root over of 5 by 9, 5 by 2 multiplied by x square minus 1 by 3. Now, this 3 if I multiply, it will come to the our original value that we start with, 3 x square minus 1. So, this is a lengthy but straightforward calculation, and I have the normalization factor here root over 5 by 2, half these things are already there, you can see it from here, and I just multiply the normalized factor, that is coming out. The point is that if a set of vector is given to you, which is set of function which is orthogonal, which are linearly independent to each other, from that by using the Gram-Schmidt orthonormalization process, Gram-Schmidt ON process, I can have a set of functions P0, P1, P2, which are, if I do that, which are linearly, which are orthogonal to each other. If they are orthogonal to each other and normalized to each other, then we can say that these things can be used as a potential basis, and this is the value we have calculated. So, with this note, today we like to conclude, and in the next class we will try to do something regarding the polynomial space that we have started in the previous class, how this polynomial space are there and all these things, and then we will conclude the first part of our course, which is linear vector space. With that, thank you very much for your attention. See you in the next class.